open them and try to see, okay, if this is a um, glasses filter, then you can see how a person can wear a glass, and how can a person wear a mask, and like, because this is augmented reality, and then you can create those kind of realities into your digital world. um, they have all kinds of capabilities like hand tracking, body tracking, body segmentation, video calling, that was new. And then based on that, it has been divided into two kind of experiences. One is like sharing experiences, and other one is video calling experiences. The sharing experiences comes with Instagram and Facebook, and then most of filters are like how we use today with body tracking. And like sharing experiences have less limitations than video calling experiences, because video calling experiences are where you kind of get on a group video call, and you can apply effects, like you can kind of play games on a video call, which is similar to kind of connecting on an application where you would play like, hey, heads up, or if you have played those games. So similar to that, video calling experiences are those kind of filters. Without any further ado, let's jump in. Okay, so if you click on blank project, it will give you a very blank project that we initially opened, and you will see the screen in front of you. And let's talk about what is augmented reality, and why are we that today's time we are actually seeing this everywhere. I think augmented reality, Spark AR is everywhere. Like, you look around, and then somewhere there's a hackathon happening. There's a company changing their names, or they're everybody is getting into metaverse, if you know about it. So this is maybe a portal to get into that. So maybe the devices in future would be obsolete. That everybody would just experiences everything rather than just talking about it. Um, Maybe if you and me could actually see each other and talk, instead of just hearing and just looking at the video, we could actually be in the same space, be in the same workspace, and kind of interact. So that would be like a next iteration of internet that's going to happen in a couple of years. And this is kind of the portal that we started working a little bit of uh, in that direction. So whatever we see in real life is augmented into um, digital world. And that means that how do we see in outside is that we have light, we have eyes, and we have objects. um, and then there is some sort of science behind it. Like, if you see an object and which is farther than your focal distance, then you can kind of see it. But if it is kind of below your focal distance or under your focal distance, then you can't see it. It's almost like you're right at the object, then you can't see it. But you have to be at a certain distance, but you can't be too far. So those are some calculations that we do when we do things in reality. So when people started to implement this into digital world, they thought like, okay, um, we need a camera to see, to be somebody's eyes. So we have our phones, and when we open our phones, and there's a camera. So a phone's camera can have a can replace our eyes. Okay, so they can have a look, like, okay, what are we looking at? So what are we augmenting at? And then there are some things which is like light. Like, we have a sunlight, and there's a constant light of source. So there we have a direction lights, we have ambient lights. Direction lights are like the kind of depending on the rotation, but ambient lights are they're kind of a constant source of light, which is same throughout the entire scene. So we needed these things. And so let's understand this. Okay, this is our viewport. This is when you open the tool, this is a viewport that um, what are you augmenting right now? This is my device. If you look at the scene panel, you will notice that there are some certain by default elements in the device panel, which is in the scene panel, which is a device, that means we have a device already set up in this augmented digital world. That device, inside that device, if you expand it, um, we have a camera already. And the camera means that this device is the next child is the camera. So whatever we are looking at through the camera, and then at a certain focal distance, we have other objects that you can lie inside. So we have, first of all, we have ambient light and directional light. So this is why a scene is lit up. This is why we have a focal distance and we can see things. So this is the scene panel, and what you can do here is you can kind of add your own things. You can add a 3D object, you can add yourself, so you can add some 2D objects. So there are like certain objects that we'll talk about, which can be added to this Spark AR um, digital world. So let's try adding something. Let's try adding a plane, maybe. What is a plane? A plane is nothing but just a representation of something, um, some combination of some coordinates which can represent something into x direction, y direction, z direction. So let's say this is a plane and which is kind of situated at the center of everything right now, because by default, and it is inside the focal distance. That means that when I click on my device, there's a certain distance where it is like projecting on the screen, right? I can look at it. That means it is at a visible distance. But if I put it, let's say I can rename it. I can call it like test testing AR, and right now it is inside the focal distance. But what if I move it out? What if I put it outside the focal distance? So right now, if you see, this is not the child of focal distance. That means where my camera is, my plane is also right with it. That means if I look like this or if I look like that, it's gonna be moving with my camera, right? It's gonna be, because it is tied to my camera. It is not at a distance, and then tied. It is actually tied to my camera point. That means that I won't be able to look at it. I won't be able to see it. And this is what is happening, because it's almost like, if you know, I mean, there's a light source, there's a darkness just just beneath it. So it's the same reason here. We can't see that this object is visible. Again, but if I take this plane, and then so right now, if I move my camera, it's gonna move with the camera. But if I take it out, and even if I put outside the camera, I can do that, right? I can put anywhere. I can put it like maybe like maybe inside like that. So if you see, the farther I go from the camera, smaller it becomes, and closer it comes to the camera, larger it becomes. But if it comes right at the camera, that means we won't be able to see it. If we get past it, we won't be able to see it. So um, I'm gonna put it like on camera at the moment. And next, if I put it under the device, like just outside the camera, also we can do that. So right now it is not part of the device. That means even if I move my device now, even if I go from here to or maybe some other location, my camera can't see it. My device has no control over it. That means it is somewhere in the world, which if I turn back, or it might be able to look at it, or but it won't be. It's in the world space. It's somewhere at some coordinate where my phone is standing, and it is some coordinate, and I don't have any control over it. So this is like a world space coordinates. And but we mostly be working inside the device and inside the focal distance. But it's good to know some things around where things are situated, what are the coordinate systems, and how they work, right? So let's go back to focal distance, and we can see it again. Now, there are certain. So when you decided that, okay, you want to have some objects, then there was a need that these objects could have some properties. These objects could be identified um, as their position, as their how big they are, what is the rotation in terms of something, and then is there a is there a material to them so that they can be They can be shinier, they can be, they can be rough. We can control the roughness and how much are they flat. Like basically, there has to be some sort of properties attached to these guys. So that is why the left panel is your scene panel where you add the objects, but your right panel, if you click on a particular added object, then the right panel is your properties, is your attributes, is your control over these scene objects. So let's say if we were just moving our plane, right? So what we were moving, we were kind of moving its position. If you see, this is the z direction, this is y direction, this is x direction. So if I move this guy up and if I move this guy down, you see there's a change in the y direction. All right, we can little bit make it a little bit bigger as well. And so this plane is right now is up a little bit ahead of the screen. So if you can like, right now this is behind the screen, so anything which comes to the screen is going to cover it if that is the order. And so yeah, you can see that the position is changing. We can how to change these things is there are some controls that you should learn over time. And these controls are, if you put control and if you drag with your mouse, if you're using Windows, that's command. But if you're using sorry, if you're using Mac, then it's a command plus the mouse drag. Or if you're using Windows, then it's a control plus mouse drag. If you do that, then you'll be able to rotate the scene in a certain axis wherever you click, and then you'll be able to rotate the scene like this, so that you are like, you can know that the positions and everything. So that's why like transformation can be adjusted. But and if you press Alt and drag, that means you can move the entire thing to like a, like basically you're moving from one coordinate to another coordinate, but shifting the entire scene into like left or right or front or back. So kind of getting familiar with okay where things are at any point of time. If you get lost, because if your project was like somewhere but you were moving and then like somehow you get lost in the scene, then how do you get back? Is that you press F, just click on something that you want to find and click on F, it will just put you in focus. All right. So and then once you're back, you can scroll it down and you can come back and see where you are. All right. um Next thing is your scale. You can like make it bigger, you can make it smaller, like those things can be done. Since it's like it's a 2D thing, the Z scale doesn't matter, so you can put it 1 as well. I think if you put it 0 also, it wouldn't matter because there's nothing in the Z direction. Um, this is the rotation where you kind of rotate it in terms of X direction, Y direction, increase the values. And there's one more shortcut to this, that whenever you select an object, there you see that there are some things that are pinned here. The first is the position, the second is the rotation, and the third is the scale, which can be used in a particular axis if you choose to. And Z won't matter because it's a 2D thing, right? So um, now now we know that okay, we can add some properties and we can change the transformations of an object. But can we also give it some colors? Can we also give it some textures? Like, of course we can. So, but I don't see a way to do it from here. So how to do that? So if you go next, you'll see that you'll find a material in an object. So this every object that you add in the scene would have a material, probably, except if you're adding retouch materials, um, retouch face mesh objects. But rest of them they have a, a material property as well. Like anything, any object which can contain a texture would also have properties as colors or like roughness. Right. So let's say you want to make some teddy bears like fluffy, and then so you want to like kind of modify everything accordingly. So let's add a material to this, and I added a material. By default, it's called material 0, but we can double click on it, and you notice that as soon as I clicked on add material, this asset panel had added a material here, which means that whatever you were working with earlier, a plane was a checkered texture, which was like there was nothing onto it. But then you added a material to it. That means to add it, you can click here, and there's a property panel, right? For everything that you see in assets on scene, properties would be here. Okay. So for the materials, it says that okay, there's a shader type, which is means like, let's say, what kind of cloth are you wearing? Are you is it a is it a is it like it kind of decides your environment also, like are you in an environment where light is affecting you, like in terms of if it is a are you on the rooftop, or are you actually in the basement, are you in a lift, are you watching a sunset, are you watching a sunrise, are you walking on a beach, whatever you're augmenting in the digital world, we kind of have to see that what are we augmenting, what is our imagination that we are trying to build in the digital world. What we are trying to build right now is let's say it's a flat background that in the back of my head, that I don't see my like those things hanging, or so this is what I'm thinking, so I'm not thinking about what kind of light I am in, and those things. So there are a couple of options here which you can choose, like a flat material. If you choose a flat material, that means the light in the scene won't affect you. It will be like a default color everywhere throughout the entire material. So unless you have gradients, that would be like changing where you're projecting texture. Then the standard material, this is by default applied. It affects what kind of lighting you have. So if I change my direction light, or let's say like the intensity of the light, that means that this is like, if I make it like a little yellowish, this would I would say that okay, this is like a, I can kind of make this thing is bigger, like say okay, and since I'm changing the property of this plane, which is testing AR, I'm gonna call this material also mat underscore testing AR, or let's call it a background. Let's give it like a background. This plane is called back, and this material is called mat underscore background. Hmm. What does this mean? That um, is that we've started defining our system to have some sort of color properties at the moment, and we said like you should have a standard material, but that means that the lighting is in the scene would going to affect my scene. Ambient light is a constant source of light, which is 20%. It's also good. If you want like too much light in the system, let's say you're kind of onto a planet where the temperature is more than 80 degrees every day, but so basically that's where you need a lot of light, and maybe you see that you're so close to sun, so probably you will need that. Direction light is kind of like an angle of light. So if you see that I'm changing the angle, it's kind of, if I give it a little bit of rotation, so you'll see that the lights on different part of this object is different. So this is dynamically changing on this. So if this have like a curve on this, then the light would be blocking by the curve, because it won't be reaching, because light travels in a straight line, right? So these are some things that we should take care about when we add the background or add a material to a object. Now, if I change it to flat, now it's a white color, obviously, because we've chosen white. You can choose any color that you want. And let's say if I choose uh, this color, it's like a good color. And now if I change any of these lights, it's not gonna matter. Okay, it's because, as I said, flat material is like, I don't care what kind of lighting in the system is. I'm just gonna be this particular color. So this is why one of the properties is we use flat material like most of the time. Standard material are mostly used with when you have details in the object, which means that you can kind of you wanna have a 3D object mostly, or you want to have some depth shown in the image. Like let's say there's a pizza, then you kind of care about the pizza has like how thin or how thick it is, rather than just showing an image. So a standard material could kind of give depth to normal 2D looking image. So which is a very useful technique that we can also learn in the future. This is to toggling the visibility again. If you like go back to your scene panel and then click on an object, you can kind of toggle the visibility as well. Coming back to the material, you can add some texture to it, which is an image that you have, and like we can do that if you have an image in your, let's say, okay, let's say if we have like these images that I have in my system, and I can click all of them, I can import them into Spark, and they would be added to my assets. Let's add some of these. I'm gonna open these, and if you see that every image that I selected is now being imported into a project. And then if you see there's like a default compression that is going on, because there is a little bit of limitation of space in the Spark here, and I'm gonna emphasize on this because the maximum size of a filter can be 4 MB, that is 4 megabytes, which is a very limited space. This has been restricted by Facebook because and Instagram as well, because what happens is that when somebody opens your filter and they apply it on the scene, that file is downloaded from the server, and then that is being applied to your scene, and then your scene is modified. So you can't really like on the go, you can't have like bigger files, because maybe you are in a place where the internet is faster. But if you especially talk about India, there are so many areas where internet is like not so fast. So to keep everybody's mind, the 4 MB was decided to, let's say, so that everybody can still use the filter and download it. Maybe in future when 5G is more prominent, when the internet speed is like faster, this won't be no biggie. This could be managed. The size could be, I think, up to 20 MB, 25 MB or something. Because when you apply an effect, you don't want to wait for like, hey, loading, right? So you want to like go on the go. Okay, our textures are in here. By default, what I do is that whenever I import the textures, I put the compressions to none. This is like a compression technique we just talked about, because there are a lot of like, if you see that the total file size of these things is 25 MB, and I am not allowed to put 25 MBs. So Spark starts compressing them automatically. Like maybe out of 25 MB, it will just convert it to 1.6 MB because it's compressed everything. So you can use these tools. They're very, very great compression tools. But at the moment, I don't want to, because I just want to use it for an explanation. So I have put them none. Okay. Coming back to our material, where we wanted to apply texture, um, we can select an image now, because as earlier when we clicked on it, there was nothing coming down, but now these images have come here. So you can say, hey, I want this thing to be my texture, but my X is not visible. Okay. So what we did is that, to a simple plane, I'm going to remove it again so that you can see the what changed. It was a simple color plane, which I said to say like, hey, have a texture, okay, and then I'm gonna put it to white so it has the original color of the texture. All right. So what we have this kind of mandala texture with us, and this texture is then applied to a plane. So the plane, which was just like a checkerboard, is now have a texture which is projected on that plane, and the plane is seen as the texture. All right. And now we have like some environment colors that you can choose. We were talking about like what kind of environment you're in. For this, I'm just not going to use it, and it's not very much important for a flat material. We're just going to add some sort of light to the colors, and it's not so good for flat material. um, alpha is very important. Okay, alpha is very, very, very important. Alpha is kind of your opacity, kind of your in your texture is alpha is responsible for which part of the entire texture is going to be seen by the user. So wherever it's white, it can be seen, and wherever it's black or gray, it can be a transparent color. That means that we are our background, if you see, was like a square, or like a plane like this, but we can only see this in a circular shape where a texture is. That means the alpha of this texture is limited to this shape. The spaces, the blank spaces that you see here, are just transparency, like there's no color there. So I hope you understand this, but we'll take more examples for this as we go ahead in the session. Now, that was the background that we wanted to go with. So this is not the background I want. I want a background which is, let's say, I want this green one, and this is called image background. And if I go back to my material and if I select this image background, so this is right now in front of my face, and I want it to go to like back of my face. So let's do that. Before that, I'm gonna introduce one last thing which is remaining, is this thing, this we've been minimizing and expanding since a long time, but I think this is something that needs the most attention right now. This is called patch editor. Patch editor is nothing but is like a way of programming. It's like people used to code a lot. They would write some code, and that code would execute. And today's world, I don't think anybody needs to be a coder, because now there are so many libraries, now there are so many tools, that even if a no coder who does not know any coding can make softwares which runs on code. And why is that? Because this is visual programming for you. um, we would write a C hash, like C++ file for helper functions, and then um, we'll do some sort of framework, and then we'll write a function to do like, hey, add two numbers, and that would take for you to, like, bunch of lines to add two numbers. So what they did is like, hey, visually, I'm gonna give you a patch. This is called a patch, and this patch will have two inputs, which you can give like 5 and you can give 10. And it's going to say that, hey, if I am add patch, then that means I'm going to add my first value to my second value, and I'm going to give you 15. So instead of if you can see this, instead of writing the code for 3 or 4 lines, my work is minimized now. Even if I'm not a coder, I can do that program, right? This is a simple operation here, but this input can be some complex calculation here. The second input could be some complex calculation here, and that could give you a simple output as adding them. So this is a very important function. I think add is used a lot every now and then. And this is just one example, okay? You have subtract, you have multiply, you have divide. So all arithmetic operations you can apply. You can take a cosine, you can take a sine, you can take a tangent of something, arctangent of something, make something of a power, negate something. So all these options are there, which I'm sure you're excited to learn about, because if you see that, is that's the math we were talking about. It's like entire math patches, what is the mod value of something, you know, what is the distance from one point to another point, and then calculates like how far is it. So that's math patches. And there are a couple of other patches. So this is like one of the categories, that math. The logic patches, these are like, hey, if if you're learning Spark and also you have your laptop, then you can make filters. If any of them is not correct, you can't learn your making filters, right? If you don't learn, and if you don't have a laptop, then there's no way you're going to make a filter. So they both has to be true. So that's the logic. So both has to be true, that means end. And if one of them has to be true, then let's say hey, if you have a laptop or your friend has a laptop, both of you can make a filter, right? So those kind of like logic patches here. There are some sort of shader patches which are like, um, just to accessing a particular point into the scene. Let's say I want to change my colors of my half of my screen, and I want to divide my screen to like four parts. Or there are some sort of those patches here, or I want to combine two different texture into one. Then there's a blend patch, and there's like a couple of patches that we can talk about. There's a SDF line, SDF circle. We can make shapes here in the patch editor. So there are face interactions like, hey, if I blink, do something. If I open my mouth, do something. If I nod my head, if I speak too loud, do something. There's audio patches. So all of these things are here in Spark, and these are going to be useful as we go ahead. So I would really encourage you to kind of go through everything, see what they do, because they've given the explanation of everything, like what this patch does, and you can always click on the documentation here, and that will take you to the learning page of Spark Air if you don't get enough information here. And coming back to enabling it again, so the background was a plane. It was a plane that means it was a square plane. Our devices are usually um, rectangle. They have larger width, larger height than the width. This is mostly the case. But now the square devices have also come, but you can always take a plane or a rectangle. They can always be interchangeable. Let's add a rectangle. Rectangle is similar to plane. It's just like a 2D thing. It doesn't have a, so there has to be a 2D canvas. If you click on canvas, that means that anything that's going to appear is going to appear here. It cannot be moved into z direction unless you put it in a world space. That is there. So if you put a rectangle inside it, the rectangle by default is a square, 100 by 100 by 100. But what we're going to do is like, hey, I want to fill my entire width. I also want to fill my entire height. That means I want it entirely covered into my rectangle. And then I wanted my material to be my background, which I already created, right? So if you see that my background is now applied to my rectangle. So my entire screen is what I did. Step one, added a rectangle. You can delete this background now. We can call this rectangle as background. And we filled the width and the height, and we said like, hey, your material should be um, that we already created, and this material can be applied to interchangeably a lot of different objects, because they're free to apply. You're free to apply to many, one or many, no, don't apply as well, but there's no point of keeping it. If you don't apply, you can delete it. um, Now there are some tiling options that you have for this. It's just like useful when you want to repeat the texture. You want to kind of tile it. Like basically tiling is dividing your dividing your scene into number of tiles, which is like, so rather than just talking about it, I'm going to show you. So this material is if I want to tile it, first of all, I have to go to the texture, and I will say that, hey, if you want to tile it, so you have to turn on the tiling mode, and there has to be like a repeat tiling mode, because you want to repeat it. In U tiling is like X tiling, and then white is like Y tiling. But this is gonna confuse you. But like since it just comes out of the texture, I should like a little bit teach you on this. So if you see that right now, I am gonna say that tile one, like that means that entire rectangle will have one tile of entire texture. But if I say that no, increase my tiling, I want to have two tilings in X direction, then it's going to divide into, like four parts, because we're repeating in X and Y. If I say I have three, then it's going to have three in the X direction. If I say four, then it's going to have a four in the X direction. Like it's basically divided into four. And if I do that same thing in the Y direction, then it's going to divide vertically. So if I put it two, there's like one, two, three, four. It It always goes into the 2 to the power something. And this is, if I put it 3, and then there's like 1 2 3 4, like 6 now. So these can be like divided in a particular ratio, and then you can like create some different kind of textures. Why this is useful? It's useful when you want to repeat the texture, probably, like show some um, different windows of your own for one particular texture. And let's say if you want to do something different on the top and do something different on the bottom, so maybe it's going to be useful there. For now, we just want one tiling. Offset is just offsetting things into like x or y direction. Blend mode is very important. Right now it's alpha. If you put add to it, that means it's going to add some transparency to it, and that means that it says like, hey, it gave a lot of light to the front material, which means kind of make it opaque and also like too light, which is not good at the moment. But you can reduce the opacity. Opacity is like how is the alpha, how white is it, how much do you want to look through it. So like basically you can, but it is not giving me the feeling that it's going in the back. So I'm going to keep it to 100, keep it to alpha only. If you keep subtract, then it's going to subtract the whatever behind it, and on the top is going to subtract the colors. So if you see that the green becomes blue because um, every color is represented from RGB, and my RGB values are now subtracted the RGB values from this texture, and this is what it gives me. So I'm gonna put it to alpha only for now. Uh, Now, whatever my camera is looking at, this is my camera, and there are some properties to this camera. There's property of the device also, but I'm gonna access some properties of this camera, and I'm gonna say like, hey, give me some texture, and that is my camera texture. So so basically, if I clicked on extraction, I extracted the camera texture out of the whatever camera was looking at, and the texture is being added here in the textures with all the other textures, the background and everything. So background is just one simple static texture, but the camera texture is like it keeps changing if I move. It's a changeable value. So if my background, if I put camera texture here, I'm gonna see my feet, right? But there's a little change. Earlier, a camera was looking at just looking at everything. If you see that it was looking at everything. If I if I don't have anything here, it's kind of looking at everything. Um, don't have it here. Kind of not. There's nothing. This is just like I'm visible because there's nothing in the middle. But if I enable this, notice here that it's gonna glow because this is the part where just my camera is projected at. So this is my camera and this is my background, and I'm gonna choose my camera texture. So if you see that this is not something that I was looking at, my camera is looking at this part, all right? And um, so let's call this background, okay? And let's have another rectangle which can hold me as a person, and then one rectangle as my background. All right, so I have a background which is called now user, and if you see that this is a very small, so but first step we do is like we fill it entirely, but let's not do this time. Let's see what happens if I don't fill it. And if I have another material for this guy and say that, hey, have a flat material, and this is called matte user. And for the background, I'm going to give the background texture. That is the background. All right. For the user, I'm going to give the matte user, and I'm going to give the camera texture. So if you see that, since my rectangle is a little bit smaller, like 100 by 100, it is projected and to have that width and height. So if I increase this manually, like of course I can do that. If I increase this manually, you'll see that the width of my camera is increasing, but it's stretched because it's not in proportion, right? So easiest way is to like fill width completely in X direction, also in the Y direction. So now if you see, there's a, why don't I see my background? Like I have my background enabled, I have my user enabled here. Why don't I see it? Um, You would have to excuse me for a moment. I think all right. Okay. So I'm back. Okay. So this user in the background is kind of behind the user, and when it says that it's behind the user, that means I can't see it. I can't. It's not actually behind the user. It's behind the camera feed. That means there has to be some sort of like some way to do it. One way I can think of is that why don't I decrease the opacity of this guy, and then but still it's not the feel that I want, right? um, so there's an option to do that. In our camera panel, there's one more thing called segmentation, and segmentation is basically segmenting something that your camera can recognize. So what if your camera can recognize a human as a person, and then segment it out? Like segment it out is like draw a line over me and cut me out of the scene. Um, so what if it can just recognize my hair, not the entire body. It can recognize my skin, like so. These are the segmentation, three kind of segmentation here. You segment the entire person, you segment just the hair, and you segment the skin. We're going to talk about the person. So if you segment the person, this will give you another texture, like just like camera texture. And then we're going to go to our user and say that I want to I want to look at my camera, but where my person is, where my person is visible. So I'm gonna check this alpha now. I told you this was very important. So alpha is my personal texture, segmentation texture. So if you see now that from my everything that was coming over this background, my body has been cut out, and from there everything became transparent, and whatever in the background was is visible. That was my background. That was my green texture. Um, Notice that this order is very important. If you put the user behind this, then the rendering order from the scene objects is always bottom to top. So this background is going to come first, then the user is going to come. So but we want to see the user first and then the background. So the order should be like this. Okay, so this is like opposite from every other tool in Spark here. The scene order is from bottom to top when you're talking about the scenes. But if you talk about the layers, then it is from top to bottom. Okay. Now what we want to do next is create something more exciting. Um, let's say we want to have a face tracker. So face tracker is another thing in the scene panel that you can add to your project. When you click on face tracker, this is added, and if I click on this face tracker, you'll notice that there are some like these arrows appeared in the scene, and they were not earlier. If I disable this or if I remove this, it won't be here. If I remove this, it will be removed. But if I say like, hey, import my face tracker, then you will see that it is going to look at my face and then see that where my face is, it's going to move with it. So basically these are the directions where I'm moving, right? Whatever the rotation and direction I'm moving. um, so this was my canvas and this is my face tracker now. In my face tracker, I can add some objects. I can also add some plane that we were adding in the focal distance earlier. Now focal distance has face tracker, and we can add some things to face tracker that is like a plane. So if I add a plane here, this is going to track my face. Like wherever my face goes, this plane is going to move. If I move it a little bit down, I can see that, yeah, it's almost like a mask over my face. So if you have to put a mask, and this is what you have to do. You have to put a plane here and then apply texture, mask texture on it. um this is one thing. Another thing, this is called something called face mesh. So if you can add a face mesh, is a mesh is like a 3D object, and if you apply on it, I'm gonna disable this guy for now, the background. So if you apply the face mask, you see that how if I was applying a plane, then plane was like a like a plain texture which has nothing, like a checkerboard. Similarly, face mesh has like no texture at it right now, but you can always add something. So if let's say that you have some transformations properties there, then you can have a new material. Let's say it's we can, right now it's by default we can add the flat material, and we're gonna say, hey Matt, users face. Okay. Um, Notice that right now we are at flat material. And let's talk about the type of material when actually, especially when you talk about the faces. So if you see that if my face is vertical right now, all I see is just white and two eyes, like. So for me, from this perspective, it seems like a plain image, it seems like a 2D, just a plain image. There's no details on it. There's no like, I can't see my nose. I can identify my nose, but if you look at the side angle, there's a nose. But since my lighting is same in the entire scene, because my flat material, it looks very weird. It doesn't look same. It looks like we are from a planet where faces are just like there's no nose, like I can see my mouth, I can see my eyes, but there's no nose unless I turn a little bit or like, see like that. So I can put a standard material where we discuss that this is kind of depending where the light is coming from. So if I look up, if you see that my eyes has like a no lights, but if I come down, that means my light is blocked by these, so it is darker a little. So this is why standard material is important. um, there are a couple of more like physically based, which is like, which is in a going to review like physically based. That means what kind of physical properties this material can have. Is like, do you want to make it metallic, like, like this is the direction light that you see, and if your face is like a made of metal, if you're a robot, then it is kind of like reflecting that light. If you put the roughness like high, that means it's not that shiny, it's rough. But if you keep it in the middle, that's like a good surface to kind of create those reflections. And so yeah, this is something that you can do with your face, make it metallic, give it like a color, and then like different colors, and make it look like a robot. Your face is shinier. Then we have face paint. This is very interesting and very useful for face. So what it did is that it just multiplied, like a kind of a gray color face mask, and then said like, made it gray and said like, it takes all the details, like it also taking my beard and everything in picture, and the like just painting it. So this is called face paint. You can you can control the opacity, how much do you want to paint, and then like if you want to make it look like a little real, then you probably want this like this color, because that's how the faces are. It's not like so white for me, but if you want to like make it super real, then more- this is like more realistic to me. This is like, okay, um, my skin color can be like this when I'm afraid of something, or like um, maybe something comes up to me, and then mm, I don't know, like there's no color on my face, or maybe like that. You can apply a texture on it. Any texture is okay on the face, and yeah, this is some things that you can do with this face paint. Then you have blended mode, which is just blending a texture with it. Not really so useful. I don't really use it much. And this is shaded code assets where, and mostly with programming, where if you know programming and you can create your own materials rather than like selecting from here, like, hey, how much light do we care about, flat standard. If you know programming, you can create your own shaders, like, hey, we see things differently than what default world does. We are own hero of our own story, so we can always do that. Retouching is important. I think you're going to use it pretty often. It kind of takes away their face attributes, improves them. If you see that if I increase them, my face is a little bit smoother. It's not that smooth. If you look at like create to zero, it's a little bit roughness. There's a little bit some. So it takes away the facial imperfections, I would say. So if you put it too much, It's like super smooth. It's just smooth it out. Like basically, if there's like dark spots, it's just gonna fill in. Um, you can apply it to the full screen. So like there's a little bit of blur added to the entire screen, but if you can only choose to apply on the face as well. This is pretty much it about the face tracker. Similarly, there are hand trackers. There are hand trackers to like track your hand. Let me add that as well. So similarly, if I add a plane here, and if I bring on my hand, this is gonna track my hand, and I can say like, "Hey, Tathastu." I can say anything with my hand, and there are a lot of filters I can make. I've been seeing a lot of filters, which is like there's a if you put your hand and this butterfly comes in and sits on your hand, and this is such a beautiful thing. Simple effects and everything is similar. You can add any object here, any 3D object, 2D object, whatever you want. Always. There's one more thing that we should learn is that this AR library. This library has bunch of stuff. There are 3D objects, there are music and sounds, there are patches that people have created that you can use as a function. Something gives you a different color, something gives you a kind of collision, and something, those things are here. Then there are like textures. These are environment textures that we talk about. Are you watching a sunset, are you sunrise, or like the rooftop, are you actually in the forest? So these are like HDRI images which kind of augment that environment for you. Then there are certain blocks. Is the block is like a combination of patches, scene objects, and materials. So they're like somebody has created a ready to made thing for you, and then you can import it, and then after importing, you can kind of just change values to see. And then the example of that, like as the face deformation, if I download it, you'll see that it is being added to your project under blocks, right? So my texture, this is my material. If I go to the block, this is face distortion. If I click on it and if I say like instantiate, then it's going to add it to my scene panel, or I can manually just click it and drag it like somewhere in the focal distance or somewhere outside of focal distance, doesn't matter. If you see, as soon as I dropped it, my eyes has become like doll eyes, like a bigger eyes. So what you can do is that there are a couple of options, the couple of properties that you can kind of change. And you can change these sizes. You can make the face distort. So this is basically giving you a 3D material, a 3D object, and the 3D object is deformed in a way that it is applied to your face. And those assets can be downloaded from Spark AR website. This is called face assets. If you go to the Spark AR website, just go to the documentation or go to the help and see the open welcome screen. And there in the learn, you will have lot of tutorials here. You will have like face assets, so you can find these assets here as well. All right, coming back to Spark, this is the deformation that we can apply. I'm going to delete it for now. Just for an example, you can import a block. And what does a block do for you is that it can give you certain functions ready-made. Yeah. All right. I'm going to delete it because we're not going to use this in our project. The hand tracking can have, let's have a 3D object. Like let's go to a 3D object. And if you see that there are so many free of cost to use. This is Spark AR is done with Sketchfab, but you can always import these 3D images and play around with it. Let's see if you have a 3D shape. Let's go for diamond because yeah, we can afford it here. So if we download it here, so under assets, there's a diamond added. And now if let's say if I want to put it in my face, so if I put it on my face tracker, by default it is on the center. So the diamond is in the center. I can choose to like put it anywhere I want. When changing the positions in the viewport, when you have like a face tracker, you see that this is always moving. So it is always useful that you pause it and then move it so that it doesn't add up unnecessary rotation. If it does, you have to reset it. And another way is to kind of reset the values from here if you want to like change. Another thing is that like I can import one object and I can put it as many times you want in the scene. So let's say if I take this diamond again and put it in my hand tracker, that means my hand is going to come with this diamond now. I'm going to delete this plane. So wherever my hand goes, this diamond is following me, right? And you can put any kind of 3D object here. And if I this goes, then my another hand is here. Yeah. So you see that this is working. You can have two objects as well. One can hand with one track and hand track and another hand track. All right. This is hand tracker. I'm gonna delete it. I'm gonna delete the face tracker as well. Coming back to a canvas that we were having in the starting is that a background is the texture that we applied, and this is our user. That's me. Um, let's add these mandalas, in the background, and then so we've got the background, we've got the user. We want to have another rectangle which says mandala. Why is deleting every time? I'm sorry. Okay, let's have another rectangle. It's gonna be mandala, and this mandala is going to be mandala 1. Again, we're gonna do the same thing, filling width and filling heights. All right, and giving it a material called mat mandala 1, and uh, give it a texture which is like a number 1. And if you see, if I have given this, but it is coming in front of my face. First issue, second issue, it is a bit stretched. If I click at it here, it should be like this. It is like compressed, and like, so we need to fix this. We need to fix this somehow. And the second thing we want to do is that it has to go to the back of the user. And I'm sure you already have guessed it how to do that, is that probably put it in the background in the middle of the user so that it is in front of the background but also behind the user. So this guy is stretched. So I'm gonna like disable my user for now so that we can kind of see the background. Why is it stretched? It's because the device size is less in width and more in height. So even if you have like a square texture, and if you project it on a rectangle, then a square is going to stretch, right? So this is why it is stretching. To fix that, what you need to do is that you go to device properties. You can bring it here. So now you're learning to work in patch editor. This is the first thing that you're doing here. It's very important. A lot of people don't learn this on their very first interaction, but I recommend this, that you use this on a very first interaction, because this is the most useful thing in Spark AR. Because if you don't consider what device people are using, then your effect is going to terribly fail. So you need to know that I need to consider if somebody is using an Android phone, if somebody using a tablet, if somebody using a like a iPad Pro, somebody using iPhone 10, or like whatever small device, big device. I need to take care of everything. So this device has some properties. It has some object, which is we'll talk about later. Then it has like a screen size and a screen scale, and there's like safe area and sets. For us, useful these two. This is like the entire object. We usually pass it to kind of calculate positions, pass the properties, like whatever you have inside this object is going to be passed to render or like something like that. But for now, we need the screen size. We need the value, how much the screen size is, how much the scale is. You see that 750 1334. This is right now by default iPhone 8, and these are like 750 pixels and 1334 pixels. And there's also like screen scale 2. That means if I divide it by screen scale, it's going to give me the exact width and height of the phone. Why is that? Why do we divide with the scale? We divide with the scale because it is kind of a, you can see that pixel density, and this is why some phones are better, some phones are worse, is that they have a screen scale that 1 pixel is representing how many other pixels. So for iPhone 10, it comes out to be 3. Like if you like right now it is 2. So if I put it to like iPhone, okay, so this is the simulator, right, where you can kind of simulate your iPhone, and then you can choose to have different devices. Like let's say iPhone 10, I want to test with iPhone 10. So if you see that the device size has changed, become a little bit lengthier, and you see that this is also changed 1125 to 2436, which is like more than what we had. And also our scale has become 3, which means that 1 pixel represents 3 pixels large. So it's kind of a pixel density that you can say that we take in picture. We're gonna come back to iPhone 8 for now. um, and so this is what I call a resolution. Like this is what we calculated. So now we have a definite resolution of and we can use like a sender patch. Sender is a like a value that you can send from one place to another place. Like if I send it from here, and if I call it like hey resolution, then I can somewhere else in the part of the patches after my calculation I can say like hey I want to have a receiver, and that receiver should be what it should be. So it will tell me like hey I have some receiver, somebody is sending resolution. So okay, I'll take that. So if I take this value out now, it is the same value that I was calculating there. And we're going to talk about these vector 2 and number in a while, but you see that this is why it is useful. And I use this senders a lot, quite a lot in my projects. uh, so this is my resolution. To calculate the ratio, we don't really need to divide it. Like we want to have a aspect ratio. So basically this is stretching, right? So I want to make sure that it doesn't stretch. That means I want to have the ratio of the width and the height. Okay, then I can make it a square again. If I have the ratio, I can multiply it and I can have a square back. So I'm gonna unpack this guy. It's called unpacking. This unpack patch. Unpack patch is, if you look at the documentation, it says like unpack a number or a vector, 2, 4, or 3 as separate number values. That means if I unpack it and if I unpack it to x and y, I will have its width and I will have its height. Strangely, this says like, hey, this is an error. This is a vector 3, and what you are actually calculating is a vector 2. Um, let's quickly talk about these data types. I'm gonna disable this so you can look at my face. It's not so pretty, but like, okay. I'm gonna just say that this is a blank value. It has nothing, just the value. I click on it, it says like, hey, it's a number value, which says 0. That means this is going to represent some numbers. If I say here Navi, if I say here Navi, that is going to be incorrect because it's a number type. All you can type here is numbers. Like I can type 50, that's okay. If you type text here, that's not okay. Okay. So we have to like define like, okay, this is your house. You can live here. You can't live in a Padosi's house, or you can live in an animal house, right? Or you can't live in a cave. Obviously you can, but like, like there are things that it should fit for, right? Um, some things we can't eat. Like it's kind of a keeper. We can say this values are like a keeper of some other values. So we have to match the type that what you can keep. All right. Then there are certain type of variable types. Let's talk about them quickly, because not quickly, like probably in detail, because these are most useful when you work in the patches. There's a boolean. If you click on boolean is basically the checkbox, like hey, if something is done or not done, if something is true or it's false. My name is Navi. It can be true or it can be false. It is true, that's why it's like hey, it's true. So if you say that like what can be true, I can say that hey, uh, equals exactly is a patch in the Spark patch explorer. And if I say that hey, is 0 exactly equal to second number? Yeah, this should give me a true value. So if I take it out, it's true. But if I say is 1 equal to 0, then it's not true. That's why it's like a unchecked value, right? I hope this is understood. And also we can have this to like a text type. Let's say Navi is equals to Navi. No, it's not. Navi is equals to Navi. It's not, because you have to consider everything. It is now. So that was equal to patch for you, and also the boolean. Then we have a color. Color is like any color. Like you just click on it and choose any color, and it's gonna have that color. Right, that input is gonna have this color, right? Um, then we have number that we just talked about, like 5, 50, whatever you want to put here. Then we have a pulse. Important, very important. So pulse and boolean, I always take this example whenever I talk about these, is that they are very similar in nature. They both can tell you something to do, um, but in a way that the pulse is short lived. It's like it's like doorbell at your house. When somebody comes, they just press it once, and the doorbell starts ringing, and it's going pee 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 pee. Somebody is at the door. But the boolean is like if you press it, then it's gonna be on forever. For an example, a light bulb. If I turn on the bulb, then it's gonna be turned on unless I switch it off. So if I turn on the light, it's gonna be on unless I turn it off. But the doorbell, it's just you turn it on, and then it does its function, pa, 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 and then it's off, right? So that is the difference. If you can remember this example, you will never be wrong in Spark here. All right. The next thing that we want to do is text, that we already did, just to hold the texture. Next, we have vector 2. All right, important. So vector 2 is nothing but just a number. Again, number is, this was a number was holding one value. So we could have somebody's phone number, or somebody's what height, or somebody's weight. Like that's a one digit value. That's a one unit value. But what if you wanna talk about property of somebody's width and height together? Hey, um, like this TV is 50-inch width and 20-inch in the height. So there are two parameters to talk about. That's why it is useful. So this is two vectors. So like in x direction you're 52, in y direction you're 100, right? So this is going to give you this two values, which is, this is x and this is y. If you want to access them, you can unpack it. If you want to access them individually, like what is there on x, what is there on y, then you can unpack it. If you unpack it, you have to unpack vector 2, because this is vector 2 and this is vector 3. That doesn't gonna match. It's not gonna match. We have to match with the keeper, and to the provider, to the receiver. Like, so these are like inputs and these are outputs. The inputs should match. This output should match to the input. That's the only way it can be passed, else it won't be able to pass. Now this x is my 52. You can see the x is 52 and the y is 100. All right, because I unpacked it. Give me two nodes differently, I can access them and I can do whatever I want. So if I have a vector 3, that means I'm probably talking about length, width, and height, or um, a position in x, y, or z. Like three parameters. So that's when it is useful. And if it is like a four parameter, then this is mostly RGBA. Like any texture would have four parameters. That means red channel, green channel, blue channel, and also alpha channel. So yeah, this is the data types, and you want to unpack it. You want to have to unpack with the similar data type unpack. So if you want to unpack this guy, you can unpack with 3 also, because this is 4, but you can't do that like unpack 2 with 3. You can unpack 4 with 3, you can unpack 3 with 2, but you can't go larger. You can go also 4 and access everything individually. All right. Okay. Now, coming back to where we were, what we're gonna do now is kind of, this is my width. 750, and height is my 1334. So I want to divide my x to divide to my y. This will give me a ratio, right? This is going to be x by y, and this is what gonna give me a sender, or maybe they're gonna give me a value is zero point 0.5. That means if my x is 1, then my y has to be almost half a little more, like zero point 0.5, right? So, but at the moment, it's 750 and 1334. We took in a ratio because what was happening that whatever my x was, the y was like almost double. So to match, have the ratio, what I want to do is that opposite it. Like, if I have zero point 0.5, then you can have 1. That's what is happening right now. But if I can have 1, then you can only have zero point 0.5, then it's gonna match for me. Um, then I'm gonna say to sender the same thing that we did to resolution, and we're gonna say like, hey, aspect ratio. You can rename it whatever you want, like whatever you want. So I just want to rename it to aspect ratio. And now, uh, remember, this is a patch editor and this is your magic works. And I really like to apply things here, but the patches also you can import everything. So whatever you see in the panel here and that has an arrow can be clicked and brought over to the panel. So if you click on it, you'll see that the diffuse texture is open to have some values here. They will be passed here. So if I whatever we are having here was like a image background. So if I click on it and if I have my image background back, this is going to do the same thing. This was happening earlier. Now, what we can do now is that this image background, this matte background, we can now I'm gonna just enable everything so that you can see. Now this is the default picture, and what I want to do is I want to transform this texture to a square texture or a texture which fits my screen perfectly. That means I need to use a texture texture transform patch. What it does is that you can scale, rotate, or reposition a 2D or 3D object based on its texture. So if we add it, you see that this has two inputs. One is the texture that you want to transfer, and output would be transform texture, right? So this is like a middle function that's going to work between these guys. Earlier, it was stretched from here to here, but are we going to say like, hey, no, we're going to modify you, and we're going to give you a corrected version of it. But this transformation is that modified version. By default it is 1. uh, let's have a 2D transform pack, because we want to change the scales now. We want to change the way this has been scaled. So the 2D transform pack lets you change this position, the scale, and its rotation. All right. um, right now it is 111, so no changes here. Okay, there's no changes. What I'm gonna do now, I'm gonna scale. It's like, as we discussed, if this is 1, this can't be 1. That's why it is stretching, because our screen size says like if it is zero point 0.5, if it is 1, then this is like greater, this is like 1.7 or something. So we have to take that in consideration, and I'm gonna bring back my aspect ratio, which is like I have to receive it because I'm sending it somewhere. And if I receive it, the aspect ratio, I'll have this value here. If you see, my value 0 0.5 is here. Then I'm gonna pack it. So we were unpacking values right earlier. We can also pack because we want to feed a 2D 2 vector value, and so we would have to convert our values to a 2 vector value. And then so my x is going to be, let's say if I put my x to be 1, then my y has to be zero point 0.5, because that's how I'm gonna make it a square. So but this is what I'm doing to the background, which is not to be done. We imported to the wrong one. We want to do this to the mandala. So I'm going to remove this. I'm going to do this to mandala. And I'm going to remove this because this is my mandala texture. Just click on it and it will come here and connect it here. So if you see, um, it has become the exactly not stretched anymore. If I don't apply this, it is stretched. If I do this, this is not stretched anymore. So you see that that was the change we just did. We modified the scales, and then now a good student can ask me that why did you just divide y by x, x by y? Why can't you divide x by y? You of course can. I did it um, because y is larger for me. So if I just do it for once, I don't have to further reduce the size, because if I do y by x, it is going to be greater than 1, right? Let's do that also. If I divide, if I divide y by x, it's going to give me a value which is larger, 1.7, and I'm going to send it again, and I'm going to call it aspect ratio y by x. Okay, it's a different value now. And if I use it here, if I use the y by x, that means that now I'm doing the different thing. Now I'm saying that if my y is 1, then my increase my x. Okay, so I'm gonna do this now. So if you see, the previous setup was, this is my previous setup. I'm gonna duplicate it. Always you can control C, control V, control D as well for the shortcut. And if you want to say that y by x, so if this is going to be y by x, then this has to be the other way around, right? So you see that the both of these is going to give me same output. There's no difference in them, and you can choose. You are free to do both of the methods, but it just is going to give you a little bit scaled image, because here we are doing is 1 and point 0.5. Here we are doing is 1.7 and 1. Okay, so now I have to like multiply it with a lesser number than 1, so that it can scale back to the screen like this. Now I'm back to my original thing. So I usually do this, but you're free to use this method also, but you have to apply a multiply in the middle. So I can do this. Yeah, all right, this is perfect for me. I'm gonna just put it here so that like, I'm gonna have a look on it. Now this is done. I'm gonna bring back my user, and if you see that, it will like look like it is in the background and then like that. So this is done. What if I want to add another mandala to it? So I'm just gonna duplicate it. Duplicating is very easy. Right click and duplicate. When you duplicate, um, the material is not duplicated, so you have to like duplicate it again. And mandala 2 is then applied to mandala 2, and then this mandala 2 should have a different texture than this, maybe number 2 or maybe number 3. All right, same thing we have to do with this again. So what we can do is that, sorry, excuse me, that's a good sign. All right, what we can do again is like copy paste it, like I'm gonna like put it in somewhere else. This is a common setup that we're gonna use. So you can control V, control V, control C, control V, and you can select and drag together things here and there. And then the aspect ratio is going to be fitted here, and we need this texture to be settled, and the material that we were fixing. This was the material that we're fixing, and if we do that, we will going to have it. All right, that's been fixed. Again, now I what I want is that I want it to like a little bigger, you know. So I'm gonna multiply, and I'm gonna multiply the scale by, let's say, zero point 0.1, and you see that the mandala 2 is rendering first, and then the mandala 1. So I'm gonna like send it to the back so that the smaller one is visible, and probably use this so that I can reduce the size. Okay. So you see that now my two mandalas are on the top of each other. What if I want to rotate them? What do I do if I can rotate them? So for rotating, you see that there's a rotation which is set to be 0. So there's a call patch called loop animation, which, as the name suggests it's gonna loop an animation from certain duration. So what I want to do is I want to have a transition number, and if I see that if I rotate it by 1, it's gonna rotating, and so it's gonna rotate until I think 360. So what I want to do is like I want to go from 0 to 360 and rotate it. So if you see that this is rotating, but it's rotating very fast, so I can I can increase the time taken to do that rotation. You can say like, hey, take 10 seconds to rotate 360 degrees, so it's slower. And for the other one, at the same time, I can say like, hey, I have another transition. Make sure like these patches, I just want to make familiar with you so that you can, find a way to play with them, understand them what they do. This is just a mathematical approach, nothing new, nothing fancier, but just that you can think out of the box, can do different things with them. This is an example to enable it. And if I this one I want to rotate in the opposite direction, then I can say minus 360. So if you see that like one is supposed going in the negative direction, and one is going the positive direction, and then bring back the user, it's in the background, like, hey, the task and it's a good filter that we just made. You can keep adding things, you can make things falling. There's something called particle emitter, particle system, which is like a, so let's say, what if now if you see that there are checkered box, but there are so many checkered box that we had in a plane. So these are particle systems. Basically, you don't have to create something which is so much in the scene. Just create it once and then you can follow. So what you need to do is um, create a particle system when you want to like snow in the scene, or you want to maybe rain, like fall some leaves or like that. So congratulations, like a confetti or something like that. So useful in that. um, let's add a material to this guy first. Add a material to this and say like, hey, my material is like, hey, matte uh, emitter, and I'm gonna say to this that you're a flat material, and the texture that you're gonna have is your hot peppers. Hot peppers is like, these are the hot peppers. I think it's like the chilies here, and there are also some lemons. So I'm just adding hot peppers for now. The size looks very small. That means I'm gonna go to emitter properties now, and these properties are so good. Like you can modify them to have like a completely awesome effect. Okay. Um, right now, I want to fix the size because size is too small. Scale is 0.01. I'm gonna say scale is 0.02, which is gonna increase this quite a lot. So if I do 0.05, it's gonna be like pretty visible. If I do 1, that's like super large. So if I do 0.1, that's like, yeah, I can see them and they're like going away. What I can also do this, I can make this like a child of my face tracker. So if I can import the face tracker and drag this particle system to my face, it's gonna track my face. Wherever my face goes, it's gonna track it, right? Another thing that I want to do is it's that it is first of all this there's a something called depth when you create like um, the materials. The depth is that you are going to be rendered on the top of everything. So if you like, if you go back or if you front, then so if you have these unchecked, and then if you go back, the thing is not visible because our face is 3D, and then there's a rectangle in front of, so we can always take care of these properties. Or alternatively, you can just put it in the back. That can also work. But for now, we since we have disabled that, we just gonna put it in front. um, Go to particle system again. We have increased the size, and I don't like the way they're spawning. They're like spawning too much, or the speed is too much, I think. And then they are alive for 4 seconds, 0.4 seconds, which is not even 1 second. So let's say they're alive for 1 second. If they're alive for 1 second, they're of course they're alive for more now. What I want to do is that the speed is too high, maybe zero point 0.1. So now it makes more sense. They're going slow, a little bit more slow. Then like okay, I can see now going them, but since my lifespan is 1 second, my speed is slow. They can only make it to this distance in that lifespan and that speed. So what I'm gonna do is I'm gonna increase the lifespan to like 4 seconds so that they can reach to the top of the screen, because the particles are emitted and they die. They are not like living forever here. Okay, I'm gonna like little bit move the the origin of this to in the y direction, so that they're like coming out of, not coming out of my eyes. So I'm gonna put it like 0.05. So they're coming like coming a little bit top of my eyes, maybe zero point 0.6. Okay. Then the birth rate is 20, is like too many chilies at the moment. What I'm gonna do is like 5 chilies at the once. So now like things are a little bit controlled. They're like not too much, not too much of emission, right? I can change and control the angle that I sprayed at. Let's say spray at 30-degree angle. So like don't go straight, go like here and there. And X direction, also like 45-degree in Y direction, and not nothing in Z direction. And you can have like a dynamicity. This is for dynamicity, like some particles go 30-degree, others don't. So like 20. And I can say like hey 20%, and you can change it any number you want. Uh, this is some scaling that you can do to increase, and this is like a, they're like coming out of as a point. You can make it like a line. So now they're coming out of above this line, and you can change the width of this line like a zero point 0.5. That means it's going to cover a bigger line. So to see this in perspective, I think it's better if you look at this. So if you see that now the spawning distance is, earlier they were here, now they're like spawning from this space, like the larger space. And the next thing that I want to do is maybe try plane. The plane is, it's just going to be a plane that's it's going to transmit it from. And there's one more thing, it's called a ring. So it's kind of a have a ring, go in a ring. So they kind of go one top of each other, because ring is like a 3D thing. So some emit from here, some emit from there. So you can see that one is going above other. Sorry. And that's pretty much, I'm gonna change it to like line because I like that. It was like kind of uniform. And the length is changing back to zero point 0.2. No need 0.4 because that is out of the screen and that would be unnecessary. Maybe 0.3 at max. Right now their space is world, like how we were putting things in the device earlier. So that means that they have a world coordinates. We can put it, so when I move like this, they're like kind of, they have like a speed of like wherever they're spawned, they're free to move in the world now. They're not controlled by my head. Only the initial emission is controlled by my head. Now I can put it to like a local space. That means wherever my local space is going, the emitters are moving with it. All right. So that's something, but I think world makes more sense to make it more realistic. And then you have like very interesting acceleration. This is very nice. Acceleration and drag, like if you use properly, they can give you wonders. Like, okay, so if I go to the acceleration, that means I just introduced gravity here. All right. So the gravity value is negatively zero point zero 0.05. That means it's downside. So if I put it to negative zero point 0.1, then it's gonna be like, then it's gonna kind of slow down my particles. Like if I put it to if I put it to zero, there's no gravity. It's just gonna go up. If I put it to positively zero point 0.1, the gravity is upwards. They're gonna go faster. They're gonna like super fast because of the gravity, right? And similarly, like if I put it to minus zero point zero 0.02, they're gonna slow it down and they're gonna come back. And if I increase the lifespan, then you can see that they're gonna come back like down. So basically, if I increase the speed here, speed with speed, yeah, increase the speed, they're gonna go up first, and because of the acceleration, they're gonna come down. Then it's almost like going up and then coming down, going up and then coming down. So this like, yeah, you can play around with emitters. There's like certain functions, certain, you can tilt it, let's say 50, 20, spin it like 30, 20, like something like add a randomicity into the object. I can duplicate the same particle and have a different material to it, call it like a matte emitter, my emitter is 0, and give it limes. Okay, but I think, yeah, if you see that there are two things now, there's lime and there's a hot peppers, but the color of the lime is very similar to what we have here, so we can change it to probably some different color to make it more prominent but realistic as well. So yeah, this is particle system. And how do you publish effect? This is like too much. I don't want too much of birth rate. Like there are so many particles per thing. I'm gonna just put it to 2. I don't want so many hot peppers and chilies to look at once. I can't see with my face, so I just want to have like few and then just show me around like whatever is going on. All right. Also, I want to like uh, put them a little down so that they like not cover my face. It's just like they can just keep popping up and going like that. So this is perfect for me. Like, yeah. Um, what I want to do now is that upload this effect to my library and then my Spark Air Hub. For to do that, there are two things you need to know. First is that you can test your effect. When you click on this test on device, this is test on device. When you click on it, you have to select an experience. What are you making? Are you making a video calling effect? Are you making an advertisement? Are you making a video sharing experiences? At the moment, we are making a sharing experiences, which is by default is Instagram and Facebook. You say done. If your capability matches, that is both supported by Instagram and Facebook, it is not going to give you any error and it's going to say like, hey, you did good, nice. Then you can test it. Then you click again and you can test it. You can send to Instagram. It is going to send a notification, a test link to your Instagram. Send on Facebook. Also, if you have a Spark Air player as a application on your App Store or your Google Play, that you can connect through USB. If you download, your phone can be connected, and then you can send the effect to the Spark Air player and then test it. I would recommend you have both, just in case if you don't have internet, you can test it out. But to see them live, it is always better to test them on Instagram. The next thing that we have is to publish it. And then to publish it, you click on publish. It takes some time and it checks like, hey, if the size requirements is okay. So if you see that 1.84 MB is everything, so that was okay. The capability meets or not. So everything that is okay. That means both are checked. That means I can. So you see the file size is 1.84. The maximum is allowed for Instagram. Is now 12 MB. Okay, they have increased the file size, I think. It was used to be 4 MB earlier. Okay. Um, Now that you have your file size like this, you can just click on upload and it will just gonna take you to the library, and it's just gonna open your Spark your dashboard where you can log in using your Facebook. And I have done in mine. I just gonna open that, and it's gonna take you there. Based on your internet speed, it can take up to a minute. Okay. Hmm. Basically, it opened here, so I'm gonna bring it here. I have two screens, so yeah. You can change the name to whatever, like my first filter, or I can call pepper, chili, hot peppers, whatever you want to say, like peppers and lime, whatever you want to call this effect. All you have to do is that where you want to upload it, select it. If you want to upload both, or you want to just upload on Instagram, it's going to be public or just one private. Which owner do you want to do this to? Yourself, your other accounts that you're managing, or your AR managers too? Because I think after a while you will be making effects for different brands, different actors, different marketing campaigns, so the people give you access to upload the effect on their page, and that's how you do it. Category is what kind of category of effect is the game? It's what is like a selfie game? It's like a color effect. Is like did you make it for a fan, or like what is like a funny? Just a mood. Like what kind of representation your effect is doing? You can select up to four categories, and then do some keywords like um, it's only something that is going to make it easier to find your effect. So let's say if you create a face filter, then you probably include some sort of what kind of face filter is it? Are you tracking a face? Are you like I don't know, like maybe some examples. Like for this one, I'm gonna say like maybe fun. So funny we've already selected in the category, but like let's say you can say chilies, or like some of those things which are like related to your effect. Then finally help your effect. Demo video must upload before you can submit for approval, and record yourself like a 10 to 15-second video where you can explain what kind of effect it is. You can send the link on your device, and then you can record a video. Share the credit if you want to share it with somebody. That's optional, of course. It's not necessary. And then you have to like submit it, and then Instagram will take some consideration on the based on your effect. Is it okay to upload it, or is it like you're violating some kind of policies? They have certain policies that you can go through. And this is it, guys. This is it. You have your first filter ready, and there are many capabilities. There are so many things to explore. You can check out my YouTube for like three videos I have on my profile, which is pretty basic, but also have some advanced stuff. Go to Reskill. I have so many videos. I think I've recorded a little bit of sessions with, I think 4 to 5 sessions where we kind of talk about every capability, so simple to complex, and then you can find on Reskill. I think if you don't know where to find them, maybe ask Ajkar. Ajkar will help you with that. And I think this is pretty much it. I know now you know that where to upload, and also like when you click on this, there's an export button. So this when you click on it, you can export this file to like a .ar export file, and that file can be also manually uploaded to the same here. Like if you want to replace something, then you can like replace the file like that. All right. So this was pretty much the session was about, and I'm gonna stop sharing my screen. Why I'm always so much zoomed up is this is StreamYard. This always happens. Yep, Yogesh, falling snow and confetti can be done using this. And oh wow, I have so many questions. Do I? Yeah, if you have any questions, shoot them here. I'm happy to answer, and you can also reach me out to my Instagram, and I'm happy to answer there as well. Yeah, please check out the Reskill YouTube channel. There are so many YouTube videos that my fellow creators has have recorded already, and those are pretty useful to understand, get around Spark here, and they can help you with that. That's pretty much it from me, Asghar. It was a
Naveen,
great session.
can you also tell them where to find the Spark AR effect ID and the owner ID? I can see some questions there.
Okay. So when you go to effects, once you submit the effect or it is under approval, um, there's a list that appears on your dashboard, and then you can just see right there. It's just right there. It's just one of the options. It's just nothing. Okay, I think Asghar, you can take this one. What is the deadline for submission? Effect ID.
Yeah,
Let
you
me show you. Let me show you for effect ID. So let's say uh, this is my effect. These are my effects, and what I want to do is let's say go to my effect, and these are all my effects. And if I click on this particular effect,
your screen is
and if
not
I,
visible, Naveen.
oh, okay, I think my screen is not shared, right?
Yes.
I completely forgot that. Thanks for reminding me. Okay, is it visible?
Yes.
Okay, so this is my main home page of Spark AR Hub, and if I click on my effects, there's like so many effects, and then if I click on one particular effect, and if I say that, hey, what is my effect ID, I can like copy effect ID, copy my owner ID, and then share it wherever I want. Also, this is also here at the end of this. There's a this is these are the effect IDs that you can see, but this can be confusing because you can't see the name at the same time. So it's always good that you click on the effect, then you go here and you copy the effect ID from here. That's how we can do.
So someone's
What is
asking
your
for your
Instagram ID?
Instagram ID.
Yeah, so I can private chat to you, and then you can probably post it.
Sure.
It's very hard to remember for me because I sometimes forget myself that how many A and how many I's do I have in that, because it's like a couple of and what is Parker ID? Can you please say how to submit? Yeah, you. I think if you have, I've covered that. And falling slow and confetti is just you have to add the texture of snow that you can find online and create yourself as well. Find online, import it, and then like make it fall from above. What we were doing is like coming from the bottom, maybe take the emitter to up, and then like make them fall. Maybe have some gravity downwards. Perfect.
Sure. Thank you, Naveen. It was a wonderful session. And
Thank you,
thank you
Asghar.
everyone for joining. So the deadline for submission is 8th of December. You guys can create your effects and submit it in the form that has been shared in the comment section, also on your emails. So just submit your AR effects and grab your goodies.
All the best, guys. All the best. Make your effects. Let us know what you make. There's a group, Facebook group, that Reskill and Spark. Yeah, it's an official group. I hope you've already joined it. Join it, post your effect, make it interactive. Let us know whatever you make. It's a simple, it's a complex, it's a game, it's a like a. I tell this to everybody. You are a hero of your own story. So whatever you make, just put it there, put it out there in the world. Like, hey, this is what I make. Do you have any suggestion for me? There are people who can suggest you some things. There's some things you can learn from them. So yeah, the first thing that you should do is like start making. Yeah.
Thank you, Naveen. Okay, what the goodies are? So the goodies are a backpack and a certificate from Facebook Spark. Yeah. Thank you, Naveen, and thank you, everyone. Have a good day.
Thank you, Askar. It was a wonderful
Thank you.
hosting with you.
Bye.
Thank you. Yeah. Bye bye.
Avnish, yes, you have to create a new effect for this program. So thank you, everyone. Bye.